AB Calculus, section 5.2, page 1. All right, from section 5.1, we had been summing rectangles of equal width. And to remember your pre-calculus, remember this sigma symbol, which means to sum. It tells you to add up a bunch of things. This I equals 1 is a counter, and it tells you where to start. This n, upper bound up here, is the stopping point. This delta x was that common width. And this f of c sub I, that is the heights of the rectangles. Which was dependent on LRAM, RRAM, or MRAM. So when we first started summing rectangles, we made them all be the same width. But these rectangles don't have to be a common width. We can make some of them very skinny or some of them very wide. Makes no difference. Let's take this function curve right here and let's look at the area underneath this curve from some spot A up to some spot B. All right, our first rectangle, maybe we want to put it right here with that height. And that is an RRAM rectangle. Maybe our next rectangle, we want to be right here. And let's make that one maybe an MRAM rectangle. They're pretty even in width here, so let's really change this next one up. Let's put the third one out here. And let's use, how about something really different? That one. That height right there that was used, that's definitely not a midpoint height. Definitely not a left hand or a right hand height. So you can have that be determined by some other height. Let's do a left hand height for this next rectangle. And let's make that one, we'll make that one really skinny. Maybe this next one, really super wide. And we can keep drawing rectangles until we get all the way down here to this last rectangle. And maybe the one before it, we'll just draw that one in as well. Here's the first rectangle, second, third rectangle. That fourth one's really skinny. That fifth one's really wide. This last rectangle down here is the nth rectangle. And this is the n-1 rectangle. We can call this starting point x sub 0, the end of the first rectangle then x sub 1, end of the second rectangle x sub 2, end of the third x sub 3, end of the fourth x sub 4, end of the fifth x sub 5, end of the nth rectangle down here x sub n, end of the n-1 rectangle x sub n-1. All right, these x values here that determine the width of the rectangles are called the partition. represented by a P. And the partition is how the widths of the rectangles are determined. So we might say that P is x sub 0, x1, x sub 2, x sub 3, all the way on down to x sub n. I want to redraw this x-axis down here. It's getting kind of crowded up there, so I'm just going to draw this, kind of expand that out. X sub 3 was pretty wide. Okay, this distance here between x sub 0 and x sub 1 is delta sub I of x. Oops, delta sub 1 of x. It's the first change in x. This one is delta sub 2 of x. It's the second change in x. And remember, these are not constant like they were before, so we have to identify them as all different. This is x sub 3 of x, etc. And this last one down here is delta sub n of x. And again, we have to do that because these rectangles are not equal width. So we have to identify their changes or their widths differently. We will continue on the next page.